Hey everyone, welcome back. Today we're going to be talking about another special case trinomial that's known as the difference of squares. So let's go ahead and let's get started. So say I have this trinomial here, and let's say I'm trying to factor it. It might look a little bit different because we have this 0x in the middle. Some of you might be wondering like, well, why is that there? But let's go ahead and let's just leave it as it is and let's see what happens. So normally, I don't know how you factor, but the way I factor is typically I try to think of two numbers that can go into 36 that can have the product of 36, in this case negative 36, but then those same two numbers need to have a sum of 0. So messing around, crunching numbers in your head, you might start thinking of some. Hopefully eventually you can come up with the two numbers 6 and negative 6. Okay, if you notice, 6 times negative 6 will get me negative 36, which checks out. That's what I wanted. But then if I add them, 6 plus a negative 6 gets me 0. That checks out. I wanted them to add a 0. All right. So that means my binomial would actually be my two binomials. One would be x plus 6, and the other one would be x minus 6. This right here is actually a difference of squares trinomial, okay? Because what we really have here, all right, is a binomial at the top. If you look at closely the middle term, 0x. 0 times x is the same as 0. So I really don't need that x there. But erasing the x also, you come to realize that, hey, I really don't even need that 0 there. So really what I have is x squared minus 36, which at first you can think that's just a binomial, but this is actually what we call a perfect or a difference of squares trinomial. Okay, that can factor into two binomials. Okay, this is what we call the difference of squares. Why do we call it the difference of squares? Because technically we are taking the difference of two perfect squares. X squared is just x times x, but 36, if I rewrite it as 6 squared, okay, 36 is a perfect square. All right, so this is the difference of squares. So most of the time, how do I spot these? Well, you're looking for two things. You're looking to make sure that this is a perfect square, and you're looking to make sure that the number at the end is a perfect square. So let's take a look at a couple examples. X squared minus 25. X squared, that's x times x. That's a perfect square. 25 can be written as 5 times 5. Also a perfect square. So for this, I would write x plus 5 times x minus 5. Or vice versa. You could switch the positive and the negative 5. You can write x minus 5 first. That would also work. But again, this is a difference of squares trinomial. It's kind of convenient when you have them like this because they're a little bit faster than normal factoring. You just have to think of what two numbers can multiply and get me 25, what two things can multiply and give me x squared. Okay, and that is the difference of squares. So hopefully now you feel comfortable with the difference of squares. Hopefully, 1, you can spot them. 2, you can factor them. They come in handy as we move forward in math into algebra 2 and in geometry sometimes. Okay, so definitely keep these in mind. These are definitely some tools to look out for when you can use them. Perfect square trinomials, that's the video we did before this one. If you don't know what that is, that's another special case you should definitely check out. Also, difference of squares, two special cases that we get when we're factoring. As always, I just want to thank you for watching. I hope you learned some math, and I'll see you guys next time.